Welcome back. This is part 2 of your work, and we're going to look at using substitution for solving systems of equations. The problem we have with graphing methods is that sometimes it's actually hard to tell what the solution is, especially if you end up with a fraction like 1.35, 2.89. It would be very hard to get this number using a graphical method if you don't have a computer. We could graph it on a program and we can find this number, but in practical terms, it's not easy to do this with your pencil and paper. So we need another way to be able to solve these problems, and substitution is one method. So substitute means to replace. And we'll see how to do that with this question. So notice you've got two equations, x plus y equals 16 as our first equation, and y equals x plus 2 as the second equation. What we do here is that we note that y equals x plus 2. So we're going to take that x plus 2 and substitute it into the first equation for y here. So you're going to end up with x plus 2 because that's equal to y, and that will equal 16. Notice how now the y has disappeared completely, which is good because now we can find x. So x plus 2 is 16. 2x equals 16 minus 2. Move the 2 to the other side. So 2x equals 14. Divide both sides by 2. So now we know the x value must be 7. Okay, we take this number and put it back into either equation. So if we put it into equation 2, we'll get y equals x plus 2, and we already know x is 7. So put 7 in there, and we'll get y equals 9. So our solution is 7, 9. That system of equation, that's your answer. Yeah. Here's example 2. So we have two equations, x plus y equals 12, 2x minus y equals 3. So there's a couple of ways to do this. Let's just take one. And I've got x plus y equals 12. I'm going to change that to be y equals 12 minus x. So just put your x on the other side and change the sign to negative. So this is equation 1. So it's the same equation, we've just rearranged it. Equation 2 is 2x minus y equals 3. That's still equation 2. So now we have y equals 12 minus x. So I'm going to put that into the second equation here. So I'll replace the y with 12 minus x. So we'll get 2x minus bracket. Now important, use a bracket here. 12 minus x equals 3. So I've got 2x minus 12. Distribute the minus sign for both. Minus 12 minus negative x is plus x. So be careful of that. Equals 3. So I've got 2x plus x, so that's 3x. And I'll move my minus 12 to the other side to be 12. 12 plus 3. So 3x equals 15. X must be 5. So divide both sides by 3. So x equals 5. So let's put that back into one equation. Let's just put it back into this one. I can see that. So your equation was 2x minus y equals 3. And we now know that x equals 5. So put 5 into here. So 2 times 5 minus y equals 3. So that will give us 10 minus y equals 3. So y must be 7. So our solution for this question is 5, 7. That's your answer for that question. So this is example 3. We've got 3x minus 7y equals 2 and x plus 4y equals 1. I would change this equation because we have an x by itself. So we would get x equals 1 minus 4y. Bring the 4y to the other side. So that's still equation 2. And equation 1, I'll write down again. 3x minus 7y equals 2, equation 1. So I'm thinking that if x is 1 minus 4y, I can substitute that into x here. So I'll have 3 bracket 1 minus 4y minus 7y equals 2. So let's expand that. 3 times 1, 3. 3 times minus 4, minus 12y, minus 7y equals 2. So minus 12y minus 7y is minus 19y. And bringing the 3 over, I'll get 2 minus 3. So minus 19y equals minus 1. The y equals minus 1 on minus 19. Therefore, y is 1 on 19. Negative signs will cancel. That's the value of y. So in this case, this question would have been difficult to solve using graphs because of the fraction answer. So now if we want to find x, I can substitute, say, this number back into 2. So x equals 1 minus 4y, and y is 1 on 19. So I'll get 1 minus 4 on 19. At this point, you can use your calculator, but I'm going to make a common denominator here with the 1. So I'll write that as 19 on 19 minus 4 on 19. And 19 minus 4 is 15 on 19. That's your x value there. So your solution was 1 on 19. That's the y value. And then 15 on 19 is the x value. Here's one more example. We have the question y equals 3x minus 1 as the first equation, and minus 9x plus 3y equals 4 for the second. So as we have y equals 3x minus 1, we could substitute that into y here. Let's do that. So I'll get minus 9x plus 3 times y, and y is 3x minus 1, equals 4. So let's expand here. The minus 9x, 3 times 3 is 9x. And 3 times minus 1 is minus 3, equals 4. Notice here, minus 9x plus 9x is gone. And you're left with this equation, minus 3 equals 4. Now, this is not true, is it? This is false. So whatever x value you put in here, it's always going to be wrong. So if x is 2, here and here, these will be gone anyway. You'll have minus 18 plus 18, which is 0. And you'll always be left with this, which is always wrong. So it doesn't matter what x value you put into this equation, we can't get a correct answer. So this means that there is no solution. No simultaneous solution to this problem. We'll learn a bit more about that when we do graphing, why this is actually happening. Okay, so you can try your questions now, and I'll look forward to seeing your answers.